This logical foundation examining implicit gender. Is being particularly pronounced. This problem is further exacerbated in underrepresented and gendered languages like Hindi, where inherent societal structures such as established gender roles deepen these existing biases. This paper addresses this crucial concern by meticulously examining Hindi gender bias in LLMs, primarily through the development of custom Hindi datasets, and subsequently highlights the broader implications and debiasing challenges inherent in such linguistic contexts. Researchers have widely studied and demonstrated how algorithms frequently reinforce existing societal biases, leading to unfair outcomes. Furthermore, these models often link professions with specific genders, thereby reflecting and strengthening traditional societal roles. A notable challenge arises because LLMs, predominantly trained on Western data, often fail to accurately capture the nuanced gender complexities present in languages like Hindi. Within the Indian context, this gender bias is deeply intersected by societal hierarchies, including those based on caste and religion, consequently requiring specifically tailored debiasing solutions. Our methodology adapted Kotek et al.'s approach using the Winnow bias dataset for detecting implicit gender bias in LLMs through ambiguous queries. However, this method cannot be directly applied to Hindi. This is because Hindi also expresses gender in verbs and adjectives, and many occupational nouns are inherently gendered, unlike English. Furthermore, India's unique socio-cultural context significantly influences how biases manifest, thereby necessitating the creation of our custom manually designed Hindi dataset. The Hind Stereo 100 dataset comprises 100 ambiguous Hindi queries meticulously crafted with gendered verbs and gender neutral occupational nouns to address linguistic nuances. This dataset employs a pairwise prompting schema featuring two ambiguous sentences followed by a co-referencing task. While an ideal LLM response acknowledges the inherent ambiguity, a biased one defaults to stereotypes such as presuming a nurse to be female. Additionally, the HEA Stereo 50 dataset includes 50 of these queries translated into both English and anglicized Hindi. To ensure ambiguity in our datasets, we included occupations that are either gender neutral in Hindi, like wakil, which is lawyer in English, and some were directly adopted from English without translating, like doctor or teacher. The datasets feature two main types of occupational pairs reflecting common Indian gender stereotypes. FM, female male pairs represent roles with contrasting stereotypes like doctor and nurse, while MM male male pairs include roles typically associated with the same gender like boss and employee. The HEA Stereo 50 dataset similarly comprises 28 and 22 FM queries. Our analysis protocol involved testing GPT-4o and Claude 3 Sonnet to assess LLM responses behavior. Bias detection was performed by flagging responses where the model failed to recognize ambiguity, evidenced by a change in answer based solely on a verb's gender. We then conducted qualitative coding to categorize and record response patterns, focusing exclusively on the first generated response for consistency. Our analysis revealed a high stereotypical gender bias in Hindi LLM responses, with GPT-4o showing a significant 87.8% bias, frequently associating occupations with stereotypical genders. Crucially, this bias also reinforced social class hierarchies as LLMs often linked lower status jobs with women and higher status roles with men, thereby reflecting and perpetuating deep rooted class and gender inequalities prevalent in the Indian society. Our findings further indicate that prompts using female gendered verbs were more prone to eliciting biased responses, 86%, reinforcing occupational stereotypes. Furthermore, LLMs frequently exhibited reasoning issues, providing grammatically incorrect or hallucinated justifications, including misrepresentations of Hindi grammar rules or asserting inherent gender roles, like claiming a lawyer must be male. We utilized the HEA Stereo 50 dataset containing 50 anglicized Hindi queries to compare bias across anglicized Hindi and the Devanagari script. Analysis revealed a significant improvement in bias for GPT-4o's performance with anglicized queries, where 46% yielded unbiased responses compared to only 18.75% for Devanagari script queries, indicating heightened bias when regional scripts are employed. English responses demonstrated lower overall bias, with 66.6% being unbiased, a significant improvement over Hindi, though biases still persisted in stereotypical profession pairs like engineer and designer. Notably, English responses were also more adept at handling ambiguity in gender neutral contexts, leading to more balanced interpretations. Despite overall lower bias, some bias patterns persisted in English responses, with 50% of FM queries and 46.6% of MM queries still exhibiting bias, often influenced by social expectations and occupational hierarchies. A notable pronoun-specific bias was observed, as queries with male pronouns showed higher bias compared to those with female pronouns. Our analysis reveals that LLMs inherently mirror societal gender biases, frequently defaulting to stereotypes based on culture norms in their responses. This gender bias is deeper within the Indian context and is worsened by Hindi's complex grammatical gender system, which fundamentally differs from English, rendering standard debasing approaches ineffective. Consequently, biased LLM responses, particularly in sensitive domains like education or recruitment systems, can perpetuate harmful stereotypes and detrimentally impact self esteem and opportunities. This underscores the critical need for tailored debasing solutions that account for specific cultural and linguistic nuances, as universal methods are inadequate for fair AI development in underrepresented and complex languages like Hindi. Our current study scope was limited to Hindi and English, utilizing two specific LLMs and a comparatively smaller, manually constructed dataset. Future research should aim to expand this exploration by testing a broader range of models and other Indic languages while also deploying more efficient and scalable methods for dataset creation to increase their size. Furthermore, our analysis solely relied on the first generated response to each query, assessing repeated queries could offer deeper insights into bias consistency. Our paper contains further details and deeper discussions, and we invite you to read our work. Thank you.